thanks for coming to this session, first session of the conference. Ooh. And I'm looking forward to this conference. I've been looking forward to it for a long time. It's going to be great. I'm really excited to kick it off. There's going to be a ton of great Kafka content and Kafka-related sessions at this event. So in this one, we're going to give you a baseline, just like a 101 to get you up to speed on what Kafka is and how you can use it. So a bit about me, Dave Klein. I'm a developer advocate at Tabular, as Amanda mentioned. Tabular is a company that was founded by the original creators of Apache Iceberg. I'm also the co-author of Kafka in Action, and I don't have it on here, but I'm also on the program committee for this event. So I got to review all the submissions for the conference, and so I can tell you with a certainty that there's a lot of great content here that you're going to be amazed over the next couple of days. So now let's get started. Okay, a little bit more about Tabular. But we don't talk about that. It's on the slides if you want to look at it later. So what is Apache Kafka? Some people still wonder. People still think it's a message queue or something like that. It's not, although with some of the recent changes or upcoming changes, you'll be able to use it more that way. But at its heart, Apache Kafka is the core of an event streaming platform. And we'll get back to this slide a little bit later on as well. But first, we're going to go back to the basics. When we talk about event streaming platform, we need to talk about what is an event. Now, I should clarify up front that you might, in reading the Kafka literature, you might also see the term record or message, and those are valid terms. I like to use event. It's I think, a very powerful and flexible logical construct, but it's all just bits and bytes in the end. But an event, the neat thing about an event is that it has both notification and state, right? So an event tells you something happened, and it also carries information about what happened. And I think it's very valuable for a lot of applications. Some may only need the notification. Some applications want only the information, the payload, but some want both, and it's there for them. In fact, different applications might even use this information in different ways. And we'll talk about how different applications can consume the same events, which is another powerful feature of Kafka. So this is an example of what an event might look like in Kafka before we send it. And when it's actually in Kafka, it's just binary. But before it's going in our applications, these events might be a JSON format like this, or they might be Avro or protobuf. But it's just a basic example. You're going to have the two main components of a Kafka event are the key and the value. And the key is usually a simple data type, not as simple as I have here, but it's usually a simple data type, often a UUID or a long or something like that. And then the value is where you have your payload. That's all your information. And it's usually some type of structured object that will have fields and different data for your event. And these events are stored in a log, which we call a topic. And the log it's a read-only or append-only, not read-only, it's append-only log, a mutable log of events. So things get added to it and they never get changed, they don't get removed or replaced. It just adds on at the end as it goes. And it's also ordered, so everything goes on in a certain order and it's read in that order that it goes on. Now, the topic's actually made up of multiple logs called partitions. And this is what makes Kafka so scalable. These partitions can be spread across different brokers. So we had 3 partitions in our example, so we can go up to 3 different brokers can be hosting that information. And each of these brokers can be working on this information simultaneously. And then the data is also usually, or can be, and usually is, replicated. So data that's in one topic or one partition, say on broker 1, it's also going to be replicated to 2 and 3. So broker 1 goes down, the data's still there, and one of those other brokers takes over as the controller for that partition and keeps it going. So the data it's very difficult to ever lose data if you have Kafka set up the right way. So as I said, the data goes onto the partitions and these topics in an order, one after another. And if you're not using a key, then the data is going to be spread not quite round robin, but close to that, but basically in an algorithm that will give it an even spread across the partitions is the goal here. But as you can see here, the order isn't quite what you might want it to be in the partitions. Now you have to keep in mind to think about is that the events are consumed by partition. So if 2 events in 2 separate partitions might be consumed in a different order. You can't control the order they're consumed in if they're in different partitions. So if you use a key, which is recommended in most situations, then the data goes in a different way. What happened in that situation is the key will be hashed, and then the hash will be modulo with the number of partitions. So in this case, we have 3 partitions, so every event key is going to be assigned to either 0, 1, or 2. And it's going to be going in that order then. So all of these A1s are going to end up in the same partition now, and the B1s in the same partition, and so on. Now, as these are consumed, you can be assured that all of those things with the same key will be consumed in the order that they are written. So if ordering guarantees are important to you, then you really do need to use a key. One thing to keep in mind with this is that now you may not have as even of a spread. So for example, if you decide to use a customer ID as your key, and you have 2 or 3 customers that represent most of your business, you're going to end up with some uneven partitions. So you can do custom partitioners to overcome situations like that, or just be more careful in how you choose your keys. So that's the way the data is written to the topics. And now as far as working with the data, what writes it to the topics and what reads it from the topics, that's the clients. Now the client library that comes with Apache Kafka is the Java library or JVM library. It'll work with any JVM language. But there are also really good libraries out there for most other languages. Python, which is my preference, has a few different libraries available, but they're also available for .NET, for Go, for Rust, for Node.js. But they all will have something similar to these 2 things we're going to talk about here, and that's the producer and the consumer. The producer is what writes the data to the Kafka topics. So a producer is a class that you include in your application in whatever language you're using. You'll include this class. You'll create an instance. You'll start using it to send the data to Kafka. And it handles things like the ordering, so it knows what partition to write it to. It'll do the hash algorithms for the keys if you have a key. It'll also do things like retries. It also handles compression. There's different compression settings you can configure on a Kafka producer. So the producer handles all that. So the producer has a lot of smarts to it. But it writes these events to the topic one after another, and then the consumer comes along separately and consumes them. One of the nice things about the consumer, which is also another class in the client library, and all the different language libraries will have a consumer. The nice thing about these is that they're completely decoupled. They don't know anything about each other. The producer doesn't know who or what or if anything's going to consume the data that's producing, and the consumer doesn't know how the data got there. It just consumes it. So the consumer comes along and it reads the data. It doesn't actually consume it. It's kind of a misnomer, actually, because the consumer doesn't consume the data and that, like, take it and it's gone. It reads the data and does whatever processing your application needs to do, but the data is still there. So events on the Kafka topic stay there as long as we want them. Right? Now, you set that with a configuration for retention, either by time. You want the events to stay there for 7 days or 6 months or a year, or by size. You can set a certain size on disk that you'll allow your partitions to grow to. After those thresholds are hit, then older events will start dropping off. But until then, they're always there and can be reconsumed or reconsumed by other applications. So the consumer does its thing, following along the producer. If the producer stops, the consumer will just wait until there's more stuff. It doesn't have any problems. Or if the consumer goes down, there's no problems, which we'll see in a minute. But one of the things the consumer does is it will, as it's reading and processing the data, it will commit an offset, which is basically the position that it's just of the event that it just worked on. So you can control this. You can do it automatically, or you can control it and do it in code. But periodically, you want to have these offsets committed, and those are written to another Kafka topic somewhere. But that allows the consumer to keep track of what it's completed so far. So if the consumer does go down, the producer will go on its merry way and continue producing. And then when the consumer comes back online, it will look at that committed offset and say, okay, I finished, in this case, 3, so I'll start up at 4 and go on from there. And so you don't have to worry about if your consumers go down, and even if a lot of events are continuing to be written by the producers, you don't have to worry about anything being skipped. It'll come back and pick up right where it left off. So here's a little bit of sample code of what a Kafka producer would look like in Java. A little bit less code if you did it in Python, but we need to go there. So it's just, in this example here, we declare the instance of the Kafka producer, and then we have a few values set up for a key and value, just some dummy data there. But then the key thing here is that once we create a new instance we create a producer record. So the producer record holds what we're going to send. Like I said, you see record quite a bit in the documentation. But this is our event. It goes into the producer record, and it's going to have the key and the value. Now, you can also pass in other things too, like metadata and some other things like that, but the main things we'll focus on here is the key and the value, and then the first thing in it is going to be the topic. So you can think of the producer record as like an envelope, and the address is the topic, and then the key and the value are what go inside. So you create the producer record, and then just call send. Now you can send, can be done either asynchronously, either with like a promise, or it can be take a callback. So pretty simple code just to send an event, and you usually would do this in either based on your application's behavior, so when things happen, an order comes in or something happens like that, or you might have it in a loop if you're sending a bunch of data. Consumer is similar. Again, you just declare it, and you give it the type. The generic thing here you're seeing is the string. That's the key, the type for the key and the value. That just tells the consumer and the producer how to work with the data that it's looking at. So the one extra step with the consumer is now with the producer, remember we set the topic in the producer record. That was like the address for the envelope. In a consumer, you subscribe to a particular topic or more. So that's why it takes a list. So we give it a list. I'm giving a list of 1 right now. But the consumer subscribes to a list of topics, and it will listen to those topics, and any events that land in those topics, it will consume them. And then we just jump into a loop. And normally you have something cleaner to close the loop up and stuff like that. But basically, you're just running in a continuous loop with your consumers and then consuming the records. And you call the consumer poll, that you give it a timeout, which just tells it how long it'll wait if there's no messages yet. It'll come back with empty if there's nothing there, but it will wait that long to see if something else shows up. So you can adjust that behavior. And then when it gets back, it's going to be a set of consumer records, or a list of them, and then you can loop through that list and process them. So that's the basic use for a Kafka consumer. Generally, your processing is going to be more complicated than what we have here. And generally, that's why consumers usually will take longer to operate on each event than it takes to send them from the producers. Which brings us to our next point, which is consumer groups. Because it's usually more work involved in processing events as you're consuming them than it is in sending them over through the producer, you often will have multiple instances of your consumer application to process that data. So the consumer groups handle the spreading out the workload of the events on the different partitions to the different application instances. So in this example here, we have 4 partitions on our topic, and we have 2 instances of our consumer group. So the consumer group automatically balances that out and gives 2 partitions to each instance. If we get busy and we have more data coming through we need to process, we can add more instances, and it'll automatically rebalance and assign 1 to each now. Then we have 4. Now at this point, we could add a 5th instance, but it would just sit there idle because the data in one partition can't be split across more than 1 instance of the same consumer application. Now there's a group ID that's used as part of the configuration for consumer applications that tells it which application is which. So all these instances have the same group ID, so they're all going to operate as one thing. But if you had a 5th one sitting there, and you might actually do this, and I've worked in some applications where we did do this, and it was basically just a standby. So it sat there idle until one of the other ones went down for some reason, and then that one would get assigned its own workload. And you can also go back if you need to. So it can scale in and out that way, and your only limit is the number of partitions. So if you've got 100 partitions, you could have 100 instances of your application running effectively, each of them processing data. And you can also have, another group. So you can have multiple applications that are consuming the same data. I mentioned that earlier, right? Because the data stays where it's at on the topics even after it's being consumed, another application could consume the same data, be looking at the same topic in its own consumer group, and those are completely independent of each other. So that's consumer groups. And it's really just a powerful construct. There's a lot of really cool stuff about how it's balanced, and there's some great talks that have been in the past that you could probably find on video that describe how that's done. That's consumer groups. Then, so let me back up just to wrap up that we talked about the producer and the consumer. Those are both part of the client library. There's also an admin component that's part of most client libraries that allows you to do things like creating topics and setting the partition sizes, adjusting things, changing things. I don't go to this talk, it's a little bit more advanced, but it's part of the client library as well. So these are all part of the Apache Kafka client library. The next thing we're going to talk about is another piece of Apache Kafka framework overall, this Kafka Connect. It's again part of the Apache Kafka project, but it's its own application. So Kafka Connect is an application that you would run usually in a cluster, and it will it contains producers and consumers basically, along with plugins called connectors that you configure and install and configure that will connect to different sources and communicate with Kafka. So in this slide here, we're looking at source connectors. So source connectors basically have that's a little gear thing there, I did the connector. So the connector will connect with something like any, if you use a JDBC connector, you can connect to any JDBC database. You might have specific ones for specific databases like Oracle, MongoDB. There's also connectors for many SaaS applications or files, HTTP. There's just all kinds. There's over 200 connectors out there. Probably more than that, but in the Connect Hub, which I think I have a link to in a minute. But so these connectors, the connectors will read the data from your source and then use a producer internally to write the data to Kafka. So this is a great way to get data into Kafka. It's really a great way to introduce Kafka to an organization as well. You can connect to an existing database. So you have an application right now. It's writing data to the database. Everybody's happy. It's all going its way. But you want to start working with Kafka to take more advantage of real-time data processing. So you can bring data in from your database right into Kafka Connect. So as it's being written to your database, you can use something like the BZM, the CDC connector, to read the data right into Kafka as it's hitting the database. And that also is done without any extra load. If you use the JDBC, then it actually issues queries to your database, which gives a little bit more work to your database, and your DBAs might get upset about that. But with CDC, you can avoid that. But anyhow, it's a great way to bring data into Kafka, and then once it's in Kafka, you can start building new applications and find new ways to take advantage of that data. And then there's this other side of it, is the sync connectors. So the sync connectors, you're basically going to consume data from Kafka, and then use your connector to send that data to your target system. And that could be a database, it could be something like Elastic or any kind of other search engine, or analytics engines. Snowflake, you can put it in S3 buckets. So there's, again, lots of sync connectors that allow you to send data to Kafka, and the connector has all the knowledge of how to write to that target system. And then Connect has the knowledge of how to read from Kafka. And all of this is configured, and one of the cool things about Connect is that you set these all up with no code at all. It's just some JSON configuration that you send to the Connect cluster, and it does all the work for you. And it also takes advantage of the scale as well. So again, you can run Connect in a cluster, so you can have multiple instances of the Connect application that are running, multiple workers running, and it can be doing a whole bunch of data, reading from lots of partitions at one time and sending that data out. And it can, again, scale up and down, or in or out, however you say that. Okay, and there's the link for the Confluent Connect Hub, which has a whole bunch of connector information. There's connectors, there's all kinds of connectors. A lot of them are open source. Some of them have a license, some of them are commercial, but you can get a lot of information about them on the Connect Hub. It'll tell you all that stuff. All right, another part of the Kafka project is Kafka Streams. Now, Kafka Streams is a library similar to the client libraries, and actually includes the client libraries. It includes the consumer and producers in Kafka Streams. But Kafka Streams is a library that is built for building, or is designed for building streaming applications. So this, again, it's a library including your application, like in your microservices or something like that, and then you can use that to subscribe to topics that become your input topics, and then run these stream processing applications on them, and then write out to other topics. So it's basically, it's stuff you could do without this library. It's all stuff you could do with just a producer and consumer, but Kafka Streams takes care of a lot of difficult work for you. So a lot of things like managing state along the way and scaling in and out is all it handles for you. So it comes with a bunch of, this is the slide here showing some methods from the Kafka Streams DSL, which are a bunch of built-in functions that you can use to do common streaming functions. So you stream, first you get your stream, you have your input topic, then you might call filter on it, which is you can filter out events based on some data in the event, if you only want certain ones, not others. You can call map, which is going to do something on every one that takes either a lambda or another method, and you can do that on every event in the topic or in the stream as it's coming through. And all these will happen in near real time as the data is arriving into Kafka. Flat map is similar to map, except it only affects the value, not the key. So with map, you can actually change the key. In fact, a real common scenario is to use map to assign a key. If you have data coming in that doesn't have a key, like maybe clickstream data or some things like that, then you can grab some value from the data, some field in the data, and use that as the key going forward, like the IP address or something like that. And map is a great way to do that. Branch is kind of like filter, but you can do it on multiple things. So you can have a whole bunch of different things you can branch on and write or filter on, and each one goes off to a separate topic or separate stream, and then eventually to an open topic. So there's reduce, there's group by. Peek is kind of a fun one. It allows you to just peek into the flow. Because often you'll have a lot of these functions chained together, and sometimes it gets kind of difficult to see what's going on. So peek is a way to see at any given instant what's going on in the stream. And then ultimately you write out to an output topic. There's a lot of other functions in there, but these are just some of the more common ones. But Kafka Streams is a very powerful library, and there's some talks about that in the conference today, or today and tomorrow. And here's, we're not going to go this in too much detail, but just as an example of a simple Kafka Streams application. It's just taking it's rating movies. So the ratings come in, there's a table of movies, and the ratings are joined to the movies, so you can get the rating for each movie that way. But you'll see in here that it's using both streams and tables, which is a key point of Kafka Streams, is that the streams are basically similar to the topics, right? It's just a bunch of events coming in order. They're constantly streaming through your system. And then tables are another way of looking at that same data, which is basically just the most recent value for a given key. Right, so now the tables are a little bit more seemingly static, although they're actually still live. They're still being updated as part of that stream. So two different ways of looking at the same data. And we'll talk about that a bit more here. There's a term people like to use called the stream table duality, which basically talks about how the streams and tables are two different ways of looking at the same thing. And you can usually go from a stream to a table and a table to a stream. But so the stream is most like the topic. It's just a continuing stream of unbounded stream of events. And every time an event comes in, it's added to your stream. A table is just the most recent value for a given key. So as a stream gets a new entry every time something comes in the topic, it's part of that stream. But the table only gets a new entry if there's a new key, right? So as long as there's just those three keys, then you're only going to have those three entries in the table, even though we've got 7 entries in our stream. So it's just the most recent value. The table will keep getting updated, the stream will keep getting appended to, is the way it basically works. Another really good analogy for the stream table is a chess game. Right? The board represents the current state, and then you also have the history, which is the stream. So the history of all the moves in a chess game, right? It's like a stream, and then it could be represented either way. At any given point, you could take a snapshot of the current stream and represent it as a table on the board. And I stole that from this really cool blog series, the link down below, so I encourage you to check that out later. All right, so now we go, those pieces I talked about, so Kafka itself, the client library, Kafka Connect, and Kafka Streams are all part of the Apache Kafka project. Now we're gonna look at some things that are beyond that, some things by Confluent, some things by other companies that are part of the broader Kafka ecosystem. So speaking of streaming, to start with, since we just looked at that, Kafka Streams is amazing, I love it. But there are other things you can do similar stuff with that aren't part of the project. So there's other libraries out there like InStream. Faust is, it's out there still. It was something started by Robinhood and I think kind of abandoned, but that's been picked up by the community and it's still moving forward. That's a Python streaming library. These next two are also Python, ByteWax, and QuickStreams. And those folks are both here. There's talks, I think, on both of these at the event. And then there's KSQLDB and Flink, which are both applications that you run and that build streaming applications inside those applications, right? But those are ones that you would have to run and manage infrastructure, set up your own cluster of instances to run those, and then they would run your applications for you. These others are all just libraries that you would include in your application, similar to Kafka Streams. And then there's also the schema registry. Schema registries are really important. The Confluent has a schema registry that's really easy to work with and works great with the Kafka client library. You can just do configuration. You can have it automatically start using it. And what the schema registry does is, well, I mentioned before how the producers and consumers are completely decoupled. They don't know anything about each other, but they do need to know about and agree on the data that they're working with, right? They need to know how to, the producer needs to know how to serialize that data from whatever form it's originally into bytes to write to Kafka topics. The consumer needs to be able to take those bytes and turn them back into something useful. And so the best way to do that is with a schema. Now you can include a schema in the events embedded in it, or you can hard code a schema in your producer and consumer applications, but now then they're no longer decoupled. As you change one, you have to change the other in sync. Or you can use a schema registry. So the Confluent Schema Registry, like I said, is really easy to use, but there are others we'll look at in a minute. But the way it basically works is that it all works similarly to this, I think, is that a producer will send an event, it'll have a schema with it. That schema will be registered or stored in the schema registry, and the schema registry will return to the producer an ID. And then from then on, that producer will attach that ID to every event. All right, then the consumer, when it reads the event, will say, oh, there's this ID for a schema. I'll grab that schema and use that to translate and deserialize this event I just received. And that those IDs and the schemas are cached. And so this only needs to happen when the schema changes or when a new producer or a new consumer comes online. So it's a great way to keep them in sync. You can control things like schema evolution with that. You can set rules for schema evolution, whether it's forward compatible, back compatible, or both. So that's a really important way to manage the change of your data as you go through time and not break your applications. And so schema registries are available at different sources. I was mostly just talking about the Confluent Schema Registry because that's the one I'm most familiar with. But Ivan also has one in their Carapace project, and as well as Amazon has Glue. So these are all basically do similar things. I'm not sure as much how these other two work, but they'll do similar things for you. So the main thing is make sure you use a schema registry of some sort, because schemas are very important in this type of work. Another place, and I mentioned here the Confluent REST API, but there's some others we'll talk about again in a second. And this is just a way of working with your events and your topics through REST. It's not normally something you would do for your main use cases, but there are some situations where you want to be able to just send occasional events to a topic through some application that doesn't have a library associated with it, so you can just use REST to send data to Kafka. And you can also consume data from Kafka topics with a REST API, with REST calls. And again, there's others out there. Confluent has theirs, like I just showed, and then there's also Carapace, which along with doing schema registry also has a REST API. And then there's Conductor also has a REST API. And I think all those, Ivan and Conductor, they're all here, so you can ask them in the expo hall. You can ask them more questions about these things if you like. I don't know a lot about either of those, again, but I know they're there. And then there's a bunch of command line tools. So there's a bunch of different shell scripts for starting and stopping the brokers. Those are the ones that come with Kafka. If you install it, like either through Docker or install it on your machine, you'll have a bunch of shell scripts that you can use to do all the basic maintenance of stuff. And there's also command line producers and consumers. Again, you don't normally use those in production, but they're great for just getting started and testing things out. You can, from the command line, just simply send data to Kafka and set up a consumer to run and consume those events. Great ways when you're first just kicking the tires with Kafka. Confluent has a CLI, which works with both Confluent Cloud and their Confluent platform. That's also very powerful and does basically all the same things. And then there's KCAT, which used to be called Kafka Cat until the Apache Foundation got on their case and made them change the name. But it's really a cool, again, command line producer consumer. But it's a lot cleaner and easier to work with than the shell scripts. And then for working with Kafka Connect, there's KC Cuddle, which is an open source project by Gunnar Morling, who's actually here. So you can pat him on the shoulder and tell him good job with that, because it's a really cool project to making it easier to work with and manage your Kafka Connect instances. So there's those things. And there's a bunch of other command line tools now, too. Ivan has one also, which I didn't include in here because I ran out of space and time. But there's, I think Conductor also has a CLI that will work with Kafka. All right, so that's the basic things I want to show you about the Kafka, what Kafka is, how it works with the producers and the consumers. That's basically the basic heart of it is just that: producing data to Kafka topics, consuming the data off those topics, and with that you can build all kinds of really cool things. And then the other components that I saw of the ecosystem, and there's a lot more out there. You can learn a lot more through the rest of this event here. But speaking of learning, I wanted to cover some learning resources that are available. Oh, sorry, why did my slides in the wrong place? What happens when you adjust your slides at the last minute? So let me go through what this is going to. I'll get to learning resources in a minute, but I told you that image I showed at the beginning would come back to it. So the idea here is that as the way you might grow an event streaming platform in your own organization, you might start out with a simple application, your client application, as a service is talking to, is reading, writing to a database. Everything's going along just fine. And then you want to introduce Kafka. So you use Kafka Connect. Now you bring that data from your database into Kafka Connect with a CDC connector. And then you might build an application that takes advantage of that data, doing some stream processing on that data, some extra processing that you weren't doing before, but now you're able to, as the data is coming in near real time, you can go ahead and process it and do something else with it. As you think of new things to do with your data, there's no limit to what you can do. And that's one of the core values, I think, of Kafka is allows you to get more value from your data as you think of new ways to use it. And then you might have another service that comes in there and just works with Kafka directly, just consumes off that topic, does something with the data, and writes back to Kafka even. Or you might bring in something like KSQLDB. And then you can start using Connect also to send data out to other sources, other sinks. So you can send data to your Elasticsearch to do further analytics there. You can send it to Postgres, Mongo, sky's the limit. There's even an Iceberg connector from Tabular. So you can send data into Iceberg for your big data needs. But that's the idea here, is that you can take these different pieces that we talked about earlier, and with those you can build out all kinds of things. And this is just one small example of the kinds of things you could build with using Kafka, Kafka Connect, and the other components. Now let's get to those learning resources. There's some great books available on Kafka and Kafka-related topics. So the top 4 up there are all available as free PDFs from Confluent. I'll have a link for that in a minute. The other 4 are books that you can get, but they're really good books on these topics. Designing data and sensitive applications isn't directly just about Kafka, but I included it because it's such a valuable book if you're working in the data space at all. But there's some books for those who still read books. There's also some cool developer websites out there. Developer.confluent.io has a lot of resources on it. Ivan has their developer portal as well, has a bunch of Kafka information on it. Ivan does a lot of other technology besides Kafka, but they have a lot of good resources on Kafka. And then Conductor has the Kafka Academy, which has a lot of cool stuff. There's also, just a link I mentioned for the book bundle. You can get those 4 books for free from Confluent. There's also the Confluent Meetup Hub, which will tell you when there's new meetups coming on, potentially in your area or potentially online. There's still some online meetups that during the pandemic it was all online, and that was kind of fun. But there's still some online ones as well as the in-person meetups, and you can find the upcoming ones in the Meetup Hub. You can also get recordings of a lot of past meetups, and there's a search thing there so you can search for certain topics and probably find 1 or more meetups that discuss that topic. There's the Confluent community. I really encourage you, if you're getting into Kafka or anywhere in the streaming space, to join the Confluent community, join their Slack. There's a lot of resources, a lot of people that are very eager to help. There's also the Community Catalyst. I'm actually the Confluent Community Catalyst, I forgot to mention that earlier, but that's a group of us that are basically dedicated to helping people in the community as much as we can when we can. So most of us will hang out on Slack and on the Confluent forum and help when we can with questions. And then my contact info if you want that. And then what was next? Oh, yeah, I am a little bit partial to Confluent Developer because I helped build it out when I was at Confluent, and I did one of the courses on there. So if you're a Python developer, please check out my course on Apache Kafka for Python developers. But probably the most popular, I think it is the most popular Kafka video that's out there anywhere, is this Kafka 101 course by Tim Birdwin. And it's still available, so this is a great intro. It'll cover a lot of things I just talked about, but it'll go a little bit more detail since it has more time than mine did. So that's a really great resource for learning. This is on Confluent Developer. But like I said, these other sites have a lot of great resources as well. And that's all I had. So I did have some time for questions if there's any.